Hello, my name is Branden Anglin, and I'm an undergraduate here at Florida State University. Today I'm here to talk to you about bacterial resistance through the exposure to antibodies. Now, what is bacterial resistance? Well, the best way to understand the topic of bacterial resistance is to look at a sample population of bacteria. Here we have our population. In this population, the gray dots represent those bacteria which are not resistant to antibiotics. The green dots represent bacteria which are resistant to antibiotics. Now, how did this happen? In all populations, there's genetic variability. This includes populations of bacteria. Genetic variability occurs when plasmids, or circular rings of DNA in bacteria, become infused into the coding region of bacteria. This affects the traits, the characteristics of those bacteria. And often, these traits can lead to an increased survival rate when exposed to antibiotics. So we have our population of bacteria, and we expose this population to an antibiotic. What this does is this eliminates the non-resistant bacteria from the population, leaving the resistant bacteria to survive. These resistant bacteria produce a second generation, and in this generation, we have an increased ratio of resistant bacteria to non-resistant bacteria. As you can see here, the green dots have become more prominent in the population than the gray dots. This is because the founding population, that population when it was just the resistant bacteria, has been able to produce more. The resistant bacteria have produced more resistant bacteria, but there is still non-resistant bacteria present in the population because genetic variability is always present. This generation can then produce two types of generations. If the trait for the bacteria, which makes them resistant to antibiotics, is not detrimental to the bacteria, more resistant bacteria will be present in the population. If the trait is detrimental, the bacteria population will return back to normal, and there will be a greater number of non-resistant bacteria to resistant bacteria. Now, what kind of resistance are we talking about here? And there's three main types of resistance which occur in bacteria. The first is the destruction of the antibiotics. This is a ballistic missile type of approach. The antibiotics are destroyed before they ever even get to the bacteria. The second type of resistance is the manipulation of the antibiotic concentration. In order for antibiotics to work, they must surpass a specific threshold. If this threshold is increased, or if the bacteria reduce the concentration of antibiotics, the antibiotics are not able to efficiently destroy those bacteria. The third is chemical changes in the antibiotic binding site. This occurs when bacteria literally change the binding sites on their surface to prevent any sort of antibiotics from binding to them, thus rendering the antibiotics useless. Now, why is it important that we understand bacterial resistance? Well, over the past years, as you can see here, resistance as a percentage has increased. Bacteria are becoming more and more resistant to a larger number of antibiotics. How can we prevent this? There's multiple ways which we can work to prevent bacteria from becoming resistant to antibiotics. The biggest one that us as a human population, that we as a human population can do, is to prevent the needless use of antibiotics. Individuals tend to use antibiotics as a crutch. They tend to rely on antibiotics for any sort of illness which they experience. This allows bacteria more and more opportunities to become resistant to the antibiotics. If we prevent that needless use, it's more likely that we will be able to slow down the rate of bacterial resistance. If we take full prescriptions of antibiotics and we prevent saving them and using them in the future, we can limit that rate of increase of the percentage of bacteria which are resistant to antibiotics. If we no longer issue antibiotics for viral infections, such as the common cold, a lot of individuals want antibiotics for the common cold. However, this is a viral infection caused by a virus, not a bacteria. So if we limit that, will once again limit the opportunity that bacteria have to become resistant to those antibiotics. So can we say that antibiotics are too much of a good thing? If we keep using antibiotics for every illness, for everything we experience that we feel antibiotics can fix, will that not increase the rate of bacterial resistance? And if we keep increasing the rate of bacterial resistance, who's to say that we won't reach a point when there's a strain of bacteria that are 100% resistant to all antibiotics? And then what do we do? Thank you.